Hello, welcome everyone. Today, in the section of 21 days free crash course, I'm starting similar figures. So, similar figures will include the 2D figures as well as the 3D figures. So, let me talk about the similar figures. What are they? Actually, it's about the two different figures that looks exactly the same in terms of uh, like shape and everything. The only difference is in their size. Just like if I draw a triangle like this and a triangle like this, if you see, they look similar. The only difference is one is a smaller, one is bigger. It's just like a miniature. If you see a miniature of something, the detailing and everything is exactly the same. Only the difference is there in their scaling. That means it seems like that whole bigger thing has now been shrunk. So that's the similar figure. So in this we can say that the similar figures are those figures that have the same angle, but when it comes for their sides they are in ratio. I'm not saying they are just random. Like if I say suppose these two triangles are similar, and if I say one side is 2 centimeters and this is 6 centimeters, so they bear a ratio. That means this is 3 times of it. So that doesn't mean like this is 4 centimeter and this is going to be 20 centimeter, that this is 5 times. No, every length will be of same scale. If this length is 3 times, now this should be 3 times as well. That means 12 centimeters. If suppose this is 3 centimeters, then this has to be 3 times of it, that is 9 centimeter. That's the meaning of the similar figure or scaling, because what's happening here, everything is as per the scale. Every length is twice, every length is thrice. It's just like that. So we can conclude that the similar figures are those figures that have same angle, but when it comes for the sides are in ratio. They bear the same ratio. Let me start with a 2D figure. Take a triangle. Let me say this is an equilateral triangle and each side is 3 centimeters. And if one side is 5 centimeters, so what ratio they are bearing? Ratio of 5 over 3. That means the bigger one is 5 over 3 times of the smaller one. So this will be also going to be 5 centimeter and this one will also be 5 centimeters, because every side will be 5 over 3 times of the smaller one. Now this is known as a scale factor. Scale factor. Now scale factor is the scalar number, that is 1 2 3 4 1.5, that scalar number by which you are multiplying a given figure to get the new similar figure. So if I say scale factor, this is A and this is now figure B. So scale factor from A to B, that means how you are transforming A to B, then it will be length of one side of B over length of corresponding side of A. So what is length of one side of B? This is 5 centimeter. And what is the length of the corresponding side? If this is 5 corresponding, that means definitely this seems to be corresponding. So corresponding side is 3. So 5 over 3 is a scale factor from A to B. If you are transforming A to B, that means if I multiply 3 with 5 over 3, I will get my new dimension, which is 5 centimeters. If you are saying that B is your original figure and you want to transform it to A, so what will be the scale factor from B to A? From B to A will be, then I can say scale factor would be defined as length of one side of A over length of corresponding side of B. So length of one side of A is 3 and corresponding side of B is 5. That means in that case, when you are transforming it from B to A, the scale factor will become 3 over 5. So if you multiply 3 over 5 to 5, you will get 3 centimeters. That is your new transform figure. In this way, you can calculate scale factor. The only difference is it will change from which to which you are transforming. Simple. But it will remain the same. That means this is the ratio of the sides or the corresponding sides of two figures. That is your scale factor. This is about the 2D shape. When we talk about the 3D shapes, then there will be the area scale factor as well as the volume scale factor as. So let me do some questions on 2D figure, then we'll move on to 3D figures. So this is also called length scale factor. Now see this question. It says ABC and DEF are two different triangles and they both are right angle triangles. Definitely the figures are not drawn accurately. The length of AC is given as 7 centimeters whereas DE is given as 3 centimeters. Apart from that, we have an information about the area of the triangle ABC, which is 28 centimeters squared. Now we have to calculate the length of FE. So I always say try to go in a reverse order. So they are asking you to calculate FE. So my reverse order thing says that if we have to calculate FE, at least we should know any length of the first triangle ABC, because that will help us in calculating FE as they are similar. So let me shift our focus on triangle ABC. So in triangle ABC, what is given? They have given the AC. Apart from that, they have given the area. And because it's a right angle triangle, I know that base is AB and height is AC. I can directly apply the formula. So formula of area of a triangle is half times AB times AC. So AB, the length of AB we don't know, but AC we know. So half times AB times AC, which is 28. So from here I'll get AB as 8 centimeters. Let me fill it. I can now clearly understand the ratio. So how AB is transforming into DE? By the scale factor of DE over AB. That means 3 over 8. So if I multiply every length by 3 over 8, I'll get my smaller figure. So just like if you see 8 centimeter, if you multiply 8 by 3 over 8, you will get 3 centimeters. Similarly, to get DF, you have to multiply it with 3 over 8. So 7 multiplied by 3 over 8 will give you 21 over 8. So this one is going to be 21 over 8. As it's a right angle triangle and they are asking you to calculate FE, so FE is a hypotenuse. So applying Pythagoras theorem, it will be FD squared plus DE squared is equals to FE squared. So FD squared is 21 by 8 whole squared plus DE is 3 centimeters. This is going to be, so this will be 441 over 64 plus 9 is equals to FE squared, and finally we'll get 1017 over 64. Root of it will give me FE. So in this way we can calculate it. Only we just need to see the corresponding side and the length scale factor. Moving on to the next question. Triangle ABC and BCD are similar triangles. Length AB and BC is given as 6 centimeters and 12 centimeters. Find the area of triangle BDC. Okay, let me just focus on what exactly everything is happening. So ABC and BCD, that means this one, and this one, they both are similar. Now what else is given? Length of AB, that means this is given as 12 centimeters. Okay, this is actually 12. and BC is 6 centimeters, so this is 6 centimeters. And we have to calculate the area of BDC. Now you might be thinking that if the length of the same triangle is given, then how can we calculate the corresponding length? But you can clearly see BC is a length of the other triangle as well. Now don't get confused that BC is same. That means BC is definitely a common length of both, like this. But corresponding side of BC of one triangle is not the BC. That means if you're saying it's like this, so if this is the base of this triangle, so this will not be the base of this triangle. Otherwise, how can be they similar? It means they are both are equal then exactly. No. So to avoid confusion, let me explain it to you. If this is a triangle and it's given as it's a 90 degree, so let me draw it separately. Obviously this triangle is not drawn accurately, so it's A, B, C, and this is 90 degrees. This is given as 12, this is given as 6. Now let me draw the other triangle, which is DCB. So if you are saying this is base of this triangle, so this is not going to be base as well. Okay, otherwise this DC will come out to be 12, which clearly you can see is a very smaller triangle and other is a bigger triangle. Though the figure is not drawn accurately, but that doesn't mean that they both are equal. They definitely seems not to be equal at all. So which means if 6 centimeter is the base of this triangle, then DC will be the base. And if AB is the perpendicular or height, then BC will be the height. So corresponding side, see, I'm just again repeating, maybe it's confusing to you. I'm saying that if you think the BC is the same corresponding side or base of both the triangle, then they won't be similar. They will be exactly equal now. Equal triangles are still similar. But here it's mentioned that one is a smaller, one is bigger. So if one is a smaller, one is bigger, their corresponding sides cannot be equal. So if BC is the base, then definitely DC will be the base of other triangle. So I can calculate length scale factor as if let's say AB be height, then in that case BC will be height. So I'm just drawing it upright like this to make it more clear. This is BCD. I have just rotated it. If AB is a height, so then, I'm sorry, it's like BCD. Then BC is the height of this one. This is 6 centimeter and this is 12 centimeters. So I'll get to know that scale factor is 2 actually. Every side is twice the other side. So length scale factor is then AB divided by BC. They both are base or height. We can consider them height. So let me say they both are height of each triangle. So this is 12. This is 6. You'll get 2 as the scale factor. That means every side will be twice of the other side. So let me just draw it again. ABC. Look at just ABC. Height is 12 centimeters. BC is given as 6 centimeters. Look at just BCD because I have rotated it. So BC is 6 centimeter. Even in horizontal way you can say BC is 6 centimeter. Now vertical way is BC is 6 centimeter. If everything is a scale factor, that means this one is twice of it. So for 6 centimeter, DC is going to be 3 centimeter clearly. Because the smaller one is half in length. 6 over 2, which is 3 centimeters. So then what will be the area of BDC? Area of BDC is half times base times height. So half times 6 times 3, which is 9 centimeters squared. This is how you can approach any question. When we will be doing the worksheets, we'll do everything in detail. More type of questions we will see, but this is the basic of understanding. Now let me move on to the 3D figure as I have explained you. So 3D figure has a length scale factor if you are calculating length, but if they are talking about the area and the volume. So for area scale factor, if you know the length scale factor, it would be very easy. Say for example, this is a figure, a cylinder, and let me see, this one is a smaller cylinder and this one is a bigger cylinder. Obviously this is not drawn accurately, I'm just randomly drawing it. If they bear the same ratio, that means this is 2 centimeters height and this is 8 centimeters height, you can clearly see when I'm transforming this to this, it's 3 times. So then area scale factor will become, there are two ways by which you can calculate the area scale factor. First way is easily the same way how we calculated the length scale factor. That means if you are transforming, let us say this is A and this is B, and if you're transforming A to B, then your length scale factor will, area scale factor will be area of B over area of A. So that you get to know that by which factor you have to multiply A so that you can get the B. Or you can say how much B is bigger than A. So if you are transforming A to B. In this way you can calculate it, calculate area scale factor. And if you remember, we have calculated length scale factor exactly in the similar manner. There is another way of calculating area scale factor which is in terms of length. So area scale factor in terms of length scale factor is LR squared. LR is length scale factor. So suppose you have length scale factor as 2. So the square of 2, that is 4, will be your area scale factor. And similarly, I can say for the volume. That means volume scale factor, if I'm transforming A to B, so volume scale factor will be similarly how we have calculated length scale factor, area scale factor, that is volume of B over volume of A. And in terms of the length scale factor, I can say volume scale factor is LR whole cubed. Whole cubed. So now let me do some questions on it. So let me see this question. It says there are two cylinders given. In given figure, curved surface area of A is 360 centimeters squared. So curved surface area is given as 360 centimeters squared. Curved surface area, that means only the curved part, excluding the upper and lower circle. That means we are excluding these two. So the only the remaining curved part is there, that is 360 centimeters squared, and the surface area of B is 40. So from this one I can easily get the idea that I have to use this one to get a scale factor. If the volume of B is 80 centimeter cube, then volume of A is. I always ask you, or always advised you to go in a reverse order. Going in a reverse order, that means what they are asking you to calculate volume of A and you need volume of B. So volume of B is already given. So I can say volume of B over volume of A will give me volume scale factor. I have volume of B which is 80, but two things are missing. That means to calculate the volume of A, I need scale factor, volume scale factor. And to calculate volume scale factor, there is another formula, because this formula is half. It's not going to help me, but this formula will help me in calculating volume of A. How can I calculate volume scale factor? We know volume scale factor is LR whole to the power of 3. So we have to solve this one. For length scale factor, at least we should have a length that we don't have. But we have volume area given. So area of B is 40 over area of A is 360. That means 1 over 9. So then length scale factor whole squared is area scale factor. We know everyone has a both formula. So length scale factor whole squared is equals to 1 by 9. From here taking root, I get to know that length scale factor is 1 over 3. So just putting this value right here, I would say volume of B over volume of A is equals to length scale factor whole cubed. Because volume scale factor is what? Length scale factor whole cubed. Putting it here, I get volume of B over, and volume of B is mentioned as 80. So let me just put the value. 80 over volume of A is equals to 1 over 27. So 27 times 80 will give me volume of A. It's 2160 centimeter cubed. So ultimately volume of A is 2160 centimeter cubed. Calculate the height. See, I have done only the thing that I have described you in theory. That means using the formulas. Either to calculate volume scale factor, you will use volume of B over A, or you can use length scale factor whole to the power of 3. Similarly, I can say for surface area or simple area, so volume scale factor would be the area of one figure over area of other figure, or length scale factor whole square. Calculate the height of the cylinder A. Height of cylinder A. If I want to calculate height of cylinder A, I can use the formula volume. So volume is because we have nothing. We have surface area and we have volume for B or A. So we need to use that. So volume of A is pi r squared h, and volume of A that we have calculated is 2160. So 2160 is equals to pi r squared h. But we have two variables. So we can use area. So surface area, that is the curved surface area of cylinder A, is we have calculated as that is given, which is 360, and it's 2 pi r h, which is 360. If I divide both these equations, equation 1 and equation 2, it would be much easier for me to divide. Either you can substitute or you can just divide. Why I am dividing? Because it will eliminate too many variables easily. 360 over 2160. Pi cancelled out. R, H. 2 over R is remaining here. And from here I can say 6. And yeah, so it's going to be 3. Finally, you can say it's 1 over 6. So it's 1 over 6. So from here, radius comes out to be 12 centimeters. If radius is 12 centimeter, put the value in either of the equation to get the value of height. So let me put it here. So 2 pi, radius is 12, height is equals to 360, or height is 360 over 12 into 2 height. This will give me pi. Height is ultimately 15 over pi. If this question comes in your calculator paper, so you just need to put the value of pi, else you can leave it like that. So that would be a final answer, 15 over pi centimeters. Moving on to the next question. Calculate the surface area of figure B if the volume of figure A is 36 centimeter cubed. Again, I'll be saying going in a reverse order. If they are asking you to calculate surface area of B, we have only one length. To calculate surface area of B is, what is surface area of B here? Surface of these 5 surfaces that you can see. First is the triangle, second is the triangle just behind it, third is the rectangle, fourth is rectangle, fifth is rectangle. It's bounded by three rectangles, two on sides and one at the bottom. So for that I should know this one, I should know this one, as well as I should know this one. And this can be done by using the other figure. So it's mentioned that they are similar. Okay, it's written up there. I'm writing here as well. They are similar figures. That is there in the question. So we need to calculate the surface area of B if volume of A is 36 centimeter cubed. Volume of A. We know volume of any prism is area of the face into length. This is given as it's 45 degrees. So let me just draw a perpendicular here. Perpendicular 90 degrees. It's given as, okay, it's written up there in the question. It has been cut out. It says that two figures are similar figures, as well as it's an isosceles triangular prism. If it's an isosceles triangular prism, that means if this is 6 centimeters, the perpendicular will divide into 3 centimeters and 3 centimeters. So if I want to calculate the area of the face of this prism, so area of triangle is, because volume of A is mentioned, and that's why I need to calculate the surface area of A, so that I can multiply it with length to get the volume. So applying tan theta. Why? Because to calculate the area of triangle, I need half times base, which is 6, into height. Height can be calculated using trigonometric ratio. So only I am writing this triangle. This is triangle 45. This length is 3 centimeters. I need to calculate height. That is, I need opposite. So tan theta I can apply to get opposite over adjacent. Tan 45 is equals to opposite over adjacent is 3. Tan 45 is 1. So I can say 1 is equals to opposite over 3, or opposite is also 3 centimeters. So I get to know that this height is also 3 centimeters. Now it would be very easy for me to calculate area of a triangle, which is half times 6 times height is 3 centimeters. So it will be 9 centimeters squared. This is the area of the face. Now volume is already given. So we know area of face into length is equals to volume of prism. Area of face is 9, length we don't know, and volume of prism is given as 36. So from here length is 36 over 9, which is 4 centimeters. So now I get to know that the length is 4 centimeters. This is 4 centimeters. If this is 16 centimeters, then what I can conclude that the scale factor would be 4 times, right? Length of B over length of corresponding side from A. 16 over 4 is 4. So length scale factor is 4. So I can write length scale factor is what? 16 over 4, because I have divided the length. I got 4 as a scale factor. They are asking you to calculate surface area of B. So if we can calculate the surface area of A rather than getting each value, or it would be very easy also, we can get to know that if this is 16, then everything is 4 times of it. So if it's 6, this is going to be 24. Height is 3, so this will be going to be 12. So everything is just 4 times now. So to calculate the surface area of figure B, I need to calculate area of each. So surface area of B is area of A area of triangles. So area of triangle is half times base was 25, height is 12. This will give you 24 into 6. And there are two triangles multiplied by 2 will give me 312 centimeters squared. Let me see the area of triangle, a rectangle. Area of this rectangle is definitely length times width. Length is 16, but this width we don't know, that we can calculate from hypotenuse. So we have the triangle, half triangle. Don't think that okay, that's very difficult. It's very easy. When you do by yourself, you'll get to know. So this is 12 centimeters. This is 12 centimeters. Hypotenuse is going to be 12 root 2. So area of rectangle will be 16 into 12 root 2 into 2, because there are two such rectangles. One this one and one this behind one. This one. And for the bottom one, it's 24 into 16, because this bottom one has length 16 and width has 24. So plus area of bottom rectangle 24 into 16. So this is ultimately 384 root 2 and this is 384. So adding all them up, we'll get a total surface area which is 312 plus 384 plus 384 root 2, which will give us 69 plus 384 root 2 centimeter squared. This is the total area. We can put the value of root 2 and get our final answer. I'm leaving it like that as of now. So this is how you can do this. So I have just merged the concept of volume, because we are calculating volume scale factor, area scale factor. So that means definitely it's going to revolve around the volume of a particular surface area of a particular given figure. So this was about the theory, and tomorrow we'll be doing worksheet on it. I'll try to incorporate all the sorts of questions in it, simple to harder, so that when you open the paper, you'll be able to solve the question, any type of question, whether it's going to be very hard or simple, any type of question. Well, I'm running GCSE batches as well. So like the paid GCSE batches, they are very affordable. The rates are very low and easily affordable. So if you want to enroll yourself to book a demo, just email us at exactacademy@gmail.com, and that is everything is mentioned even in the description box as well. Or if you want only the doubt sessions, so for that also just drop us an email. So that's it for today. Thank you. Have a great day.